All right, you guys, chapter 4. Hey, we have something pretty exciting here in this chapter. This is one of my favorite chapters, and that is because it is graphing. So do you have any idea what the sine of X graph looks like? Maybe you've studied it before. I know some of you guys are taking physics, and this really applies to physics and what you're going to be using if you go into any sort of engineering or anything physics related. This is really life applicable stuff, but what we're going to do is we're going to use the stuff we learned about the unit circle, and we are going to apply that to graphing right now. So very first thing we're going to do is we have this t-chart that's actually written sideways. And you should know by now, you should be really comfortable with figuring out what the sine of 0 is. What's the sine of pi over 2? What's the sine of pi? Okay, so I'm going to fill out that t-chart really quick, and then I'm going to talk to you about how that applies to the graph. So again, remember, sine of 0 is 0, and that's because, remember, sine is y over r, and the y value at 0 on the unit circle is 0. So get 0, 0 for my first point. Sine of pi over 2, again, y over r, the y value at pi over 2 is 1, and r is always 1. Sine of pi is 0, sine of 3 pi over 2 is negative 1, and sine of 2 pi is 0. So all that stuff that we've learned about the unit circle is going to continue on into this chapter. But how does this translate into a graph? So these are our x values, and you see I have a graph here, but my x is like really long, and that's so that I can label the x values appropriately. And the sine of x is our y values, okay? So you can see that the y values go from 0, 1, 0, negative 1, 0, and that process would repeat if we would continue to work our way around the unit circle more and more times. But I'm just going to graph, this is called just one period, and I'll get to that in a second, but when you go from 0 all the way around to 2 pi, that is considered one period. We'll get to that in a second, but I'm going to label my x values. So this is 0, put pi over 2 right here, put pi right here, 3 pi over 2, and the whole circle is 2 pi. This is 1 up here, and this is negative 1. Okay, so 0, 0 is my first point. Pi over 2 comma 1 is my second point, 0, negative 1, and 0. And so what does this look like? How do we connect it? It literally makes like a wave, which is very exciting. And make sure you put arrows on the end of it because it continues in this pattern around and around the circle. The sine wave continues. It's continuous. It's referred to as a sine wave because it's like waves in the water where they just continue to ripple. Okay, let's talk about domain. So domain and range is an Algebra 2 topic. The domain has to do with all the x values. Remember, because those are in alphabetical order, domain comes before range, x comes before y. That's how I remember which one's which. The domain in this case, because it goes to the left forever and to the right forever due to the arrows, is all reals or negative infinity, positive infinity. The range, that considers the up and down movement, and it does not go up forever and down forever. It bounces between negative 1 and positive 1. And there are actual values here at 1 and negative 1, so that's why I'm going to put a bracket on negative 1 and 1. If they were open circles, which they won't be in this chapter, but that's when you use the parentheses. That's just remembering from Algebra 2 again. Okay, let's do a similar one. So this is the shape of a sine graph. It looks like a wave. And as you know, like when you did in Algebra 2, you did a bunch of stuff with parabolas, remember U-shapes, and you learned how to make a parabola which looks like this. You don't have to write this down. But we learned how to move it to the right, to the left, up, down, and how the equation would change. You could make your parabola skinnier and fatter. You could reflect it upside down. So we're going to do all of that kind of stuff with the sine curve. And we're also going to do that for the cosine curve. So let's do a similar example here. Go ahead and fill out the t-chart for cosine. Hint, they are not the same values as they are for sine, but we're going to fill it out the same exact way. So at 0, remember the cosine of 0, that's x over r, and at 0 degrees, the x value is 1, so 1 over 1 is 1. At pi over 2, it is 0 because the x value is 0. At pi, it's negative 1. 3 pi over 2 is 0 again, and all the way around the circle we get to 1. So very similarly, I'm going to put 0 here. I'm going to label my x values, 3 pi over 2 and 2 pi. Again, the values go between negative 1 and 1 as far as the y goes, but cosine starts at 0, 1. So my first point is here. then here, and I'm just using my t-chart to graph these points. And again, you connect them like a wave, so make sure you put arrows. It does continue around and around and around the circle, but again, from 0 to 2 pi going around one full circle, that is considered one period, and that's typically how we graph the trig functions. We graph one period of them and just put arrows on the ends. So again, domain and range, exactly the same as the sine of x. So the domain again is all reals because of the arrows. It goes to the left forever and to the right forever. It continues. It does not go up and down forever. Again, it bounces between 1 and -1. So we write the range the same way we did for sine. It goes between -1 and 1. And so now I want to introduce to you a new vocab word. It's amplitude. So on the next page, go ahead and fill in the definition here. Half the distance between the max and min values. So what I like to refer to the amplitude as, I'll just give you a little bit of a hint. This is not mathematically correct, but this is how I refer to it, is how humpy the curves are. So what that means is if we look up at this cosine graph, the maximum value here is 1. And the minimum value here is -1, so the distance between those 2 points is 2. I'm going to put a 2 here, and that means that the amplitude is half of that, which is just 1. Basically what that means is we used y values of 1, and that is the lead coefficient of what this graph was, is that we just had a 1 in front of the cosine here. But keep in mind, if we have a multiplier in front, like a 2, that would actually start my value up here at 2, 0, -2, 0, and +2. And same thing for sine. That graph up here, again, the minimum value was -1, and the maximum value was +1, and the distance between those is 2. And that means that the amplitude for this one as well was 1. It's half the distance between the min and the max. That's what it's defined as. What I like to think about it as, it's the coefficient in front of the sine or the cosine. That's exactly what the amplitude is. Okay, so that's kind of a new vocab word. And I have another example here that we don't have to graph. If you notice that we graphed the sine, which is this red dotted curve right here, and we graphed one period of it. So if you look up at your notes, the very first graph that we did, it looks exactly like this red dotted curve here, but they also continued it into the negative half of the graph as well because it continues forever. So this is actually 2 periods. And so from 0 to 2 pi is considered 1 period, and from 0 to -2 pi over here, that's a second period. Anyways, this is our t-chart that we did for sine, but what happens if I would shove a 2 in front of it? That would just multiply all my y values by 2. And so that's why, notice how instead of at pi over 2, 1, this point is up here at 2, and that's because I multiplied all my y values by 2. Multiplied this value by 2. Again, I multiplied the zeros all by 2 as well, but 0 times anything is 0. So do you see how this blue curve is more humpy than the original red one? And that, my friends, is what a multiplier in front of the function, the trig function, does. If it was a 3 here, that would mean I would go from 0 all the way up to 3 for my next point, and then 0 and -3. And that's what the amplitude does. So I want to do one more example down here, and that is the b value. And so this is another really important topic. So I wrote some stuff down for you to copy down into your notes. So notice how what we just talked about was if there's an amplitude, and that would be if there's a number in front of the trig function. So this is just an amplitude of 1 because there is not a multiplier in front of the cosine, or if this was a sine graph, same thing. But notice how there's a multiplier here with our x value. That's referred to as b. And in order to figure out what our period is going to be, basically how long I am going to graph my trig function, you have to do this 2 pi over b situation. So this is a formula that you're going to want to have memorized because this is going to help us figure out what tick marks to put down here on our x-axis. And so a normal period, like I talked about in the 2 examples above, those were just 0 to 2 pi. However, that number changes if you have a multiplier here in front of the x. This is called the b term. So there's a 2/3 here multiplying by the x, and what you're supposed to do in order to figure out the period is you do 2 pi over b. And so what that's going to look like for this example is I'm going to do 2 pi divided by 2/3 because the b was 2/3, and I'm going to flip and multiply. So that means flip and multiply by the denominator. The 2's cancel, so my entire period is 3 pi, and that means that's where I stop graphing my graph. So instead of stopping at 2 pi for this example, I'm stopping at 3 pi. And here's another crazy thing, is how do I figure out what all of these other tick marks are? Well, here's where being decent at fractions comes into play. So each tick mark of this is going to be 3 pi divided by 4 because I have 4 tick marks. Okay, so this is kind of a tricky thing, but first of all, figure out the period doing the 2 pi over b situation, and that number represents your very last number here on your x-axis for one full period. In this case, the period is 3 pi. I'm going to write that because I didn't earlier. And then to figure out how to label each tick mark, each one is worth 3 pi over 4 units. So that means that my very first one is going to be labeled 3 pi over 4. And then if I add 3 pi over 4 each time, that's why I divided by 4 there, because I have 4 tick marks, that's going to give me 6 pi over 4. Yes, that reduces. I'll do it in a second. I'm going to add 3 pi over 4 again. And I'm going to continue my way all the way down. 3 pi over 4 plus 6 pi over 4 is 9 pi over 4. And then again, one more time, if I add 3 pi over 4 there, I actually get 12 pi over 4, which reduced to 3 pi. So again, this one can reduce to 3 over 2. You always want to have these reduced if you can, but now I have my x-axis all labeled. It's a little bit messy, so you can feel free to erase or whatever, but now I have all my tick marks labeled, and the entire period is represented all the way through to 3 pi here because I had a b value. And so what's the amplitude here? The amplitude is just 1, so I don't need to worry about having a higher hump or a lower hump on this graph. And so now the last thing is, where does my first dot go? Does it go here or does it go here? So you can scroll up to look at the cosine graph, but again, remember at 0 degrees, what's the cosine of 0? The cosine of 0 is 1. That's why it starts right here. The sine of 0 is 0. So sine starts here, cosine starts here. So my first dot goes right there. And then my second dot is here, and it just follows the pattern, you guys. So all of these have a pattern, but it's hard to figure out like what to label all your x values. That's the confusing, trickier part. So I'm going to connect these with my cosine wave, put little arrows on the ends. And again, that represents one period, which is different of this problem because of the multiplier here, the b value. We had to go through and do 2 pi over b, which gave me 3 pi, which tells me that is the very end of my one period that I'm going to graph. Put your other tick marks in, take whatever the period is and divide it by 4, and that represents each of your tick marks. And then you just have to remember the pattern for cosine. It starts at 1, it goes to 0, down, back to 0, and 1. Okay, I'm going to save these last two examples for in class just to make sure that we're all on the same page. But hopefully this is another topic that it might seem a little bit tricky or confusing at first, but with more and more practice that we're going to do in class, you guys will get better and better at it. Graphing is one of my favorite chapters, you guys. Welcome to Chapter 4, Graphing Trig Functions. I'll see you tomorrow. Thanks for watching.